Mathematics, the ancient art of turning numbers into headaches and equations into existential crises. But fear not, brave souls, for I am here to guide you through the treacherous terrain of numbers, shapes, and mind-boggling concepts, with a healthy dose of humor and a sprinkle of sarcasm. First up, let's tackle algebra, or as I like to call it, the alphabet soup of mathematics. You've got your x, your y's, and your z's, all floating around like lost letters in a sea of confusion. But fear not, for algebra is just like solving a puzzle, except the pieces keep changing shape and color every time you look away. Next, let's dive into geometry, the study of shapes, angles, and the eternal quest to find out why triangles are so darn stubborn. From circles to squares to hexagons, geometry is like playing Tetris with real-life objects, except instead of clearing lines, you're trying to prove theorems and avoid existential crises. Now, let's talk about those pesky drawn formula pictures, also known as graphs. Whether it's plotting points on a coordinate plane or graphing functions on a Cartesian grid, graphs are like the visual representation of mathematics' inner turmoil. It's like trying to capture the elusive beauty of a mathematical concept in a two-dimensional doodle, except the doodle keeps moving every time you blink. But fear not, my friends, for mathematics is not just a beast to be tamed. It's a wild, wacky adventure waiting to be explored. So grab your calculators, sharpen your pencils, and let's embark on a journey through the absurd and the sublime, the hilarious and the horrifying world of mathematics. And remember, in the immortal words of Albert Einstein, do not worry about your difficulties in mathematics. I can assure you that mine are still greater. So let's embrace the chaos, laugh in the face of uncertainty, and calculate our way to enlightenment one equation at a time. Embrace the chance to study now, as your success solely depends on you. Seize the opportunity, and let your determination and effort pave the path to knowledge and greatness. Remember, do the things to yourself because nobody else will. Title: Exploring Mathematics, Practical Examples and Exercises. Introduction. Welcome to the world of mathematics, where equations and formulas reign supreme. In this comprehensive guide, we'll delve into the practical applications of algebra, geometry, calculus, and statistics through real-world examples and exercises. From solving equations to calculating areas, rates of change, and probabilities, get ready to flex your mathematical muscles and sharpen your problem-solving skills. Part 1. Algebra example. Problem. Solve for x. 2x plus 5 equals 17. Solution. To solve for x, we need to isolate it on one side of the equation. First, subtract 5 from both sides. 2x equals 17, 5 equals 12. Then, divide both sides by 2. X equals 12, 2 equals 6. So, the solution is x equals 6. Exercise 1. Question. Solve for y. 3y 7 equals 22. Explanation. Similar to the example, we need to isolate y on one side of the equation. First, add 7 to both sides to get 3y equals 22 plus 7 equals 29. Then, divide both sides by 3 to find y. Y equals 29, 3 equals 9.67. Rounded to 2 decimal places. Therefore, the solution is YH 9.67. Part 2. Geometry example. Problem. Find the area of a rectangle with length 8 cm and width 5 cm. Solution. The formula for the area of a rectangle is length multiplied by width. So, area equals length times width equals 8 cm times 5 cm equals 40 cm. 2. Therefore, the area of the rectangle is 40 square centimeters. Exercise 2. Question. Calculate the perimeter of a square with a side length of 10 meters. Explanation. The perimeter of a square is the sum of all its sides. Since all sides of a square are equal, we can multiply the side length by 4 to find the perimeter. Therefore, the perimeter of the square is 10 meters times 4 equals 40 meters. Part 3. Calculus example. Problem. Find the derivative of the function f(x) equals 3x to 2x plus 5. Solution. To find the derivative of a function, we apply the rules of differentiation. The derivative of f(x) with respect to x is denoted as f'(x), or di dx. Using the power rule, the derivative of xn is nxn1. So, f'(x) equals d dx 3x2, d dx 2x plus d dx5 equals 3 2x2 1 2 1 1 1 plus 0 equals 6x2. Therefore, the derivative of fx is f'(x) equals 6x2. Exercise 3. Question. Find the integral of the function g(x) equals 4x3 2x2 plus 7 with respect to x. Explanation. To find the integral of a function, we apply the rules of integration. The integral of a function represents the area under its curve. Using the power rule for integration, the integral of xn with respect to x is 1n plus 1 xn plus 1 plus c, where c is the constant of integration. So, the integral of gx is plus gx dx equals 4 3 plus 1 x3 plus 1 2 2 plus 1 x2 plus 1 plus 7x plus c equals x4, 2/3 x3 plus 7x plus c. Part 4. Statistics example. Problem. Calculate the mean, median, and mode of the following dataset. 10, 15, 20, 25, 25, 30, 35. Solution. Mean. Add up all the numbers and divide by the total count. 10 plus 15 plus 20 plus 25 plus 25 plus 30 plus 35. 7 equals 23. Median. Arrange the numbers in ascending order and find the middle value. Since there are 7 numbers, the median is the 4th number, which is 25. Mode. The mode is the number that appears most frequently. In this dataset, 25 appears twice, making it the mode. Therefore, the mean is 23, the median is 25, and the mode is 25. Exercise 4. Question. Calculate the standard deviation of the following dataset. 5, 10, 15, 20, 25. Explanation. The standard deviation measures the dispersion or spread of a dataset. To calculate it, first find the mean of the dataset. Then, subtract the mean from each data point, square the result, find the mean of those squared differences, and finally take the square root of that mean. Following these steps, the standard deviation of the given dataset is calculated as follows. Mean equals 5 plus 10 plus 15 plus 20 plus 25, 5 equals 15. Next, calculate the squared differences from the mean. 5 to 15 2 plus, 10 to 15 2 plus, 15 15 2 plus, 20 15 2 plus, 25 15 2 equals 250. Then, find the mean of these squared differences. 255 equals 50. Finally, take the square root of this mean. 50h 7.07. Therefore, the standard deviation of the dataset is approximately 7.07. Conclusion. Mathematics is not just about numbers and formulas. It's a powerful tool that can be applied to solve real-world problems and unlock new insights into the world around us. By mastering algebra, geometry, calculus, and statistics, we gain the ability to analyze data, make informed decisions, and navigate the complexities of the modern world. So, embrace the challenge, tackle the exercises with gusto, and let the magic of mathematics lead you on a journey of discovery and enlightenment. Absolutely. In addition to diving into the fascinating world of mathematics with these examples and exercises, your engagement with this video is crucial for spreading the knowledge and helping others learn. Liking, sharing, and commenting on this video not only show your support for our content, but also help boost its importance and visibility on YouTube, reaching more people who can benefit from it. Furthermore, subscribing to our YouTube channel ensures you never miss out on our latest math tutorials, tips, and tricks. By subscribing, you'll stay updated with new content and have access to a wealth of resources to enhance your mathematical skills. Your feedback and interaction are incredibly valuable to us. Every like, share, comment, and subscription will be carefully considered and appreciated. So, don't hesitate to hit that like button, share this video with your friends and fellow math enthusiasts, and drop us a comment with your thoughts, questions, or even suggestions for future topics. Together, let's build a vibrant community of learners and educators, united by our passion for mathematics and the pursuit of knowledge. Thank you for your support, and let's continue to grow and learn together.